Let's start our discussion of reflection with a flat or plane mirror. And some terms that we need to define. First, we have the incident ray, the incident light ray, which is the incoming ray towards the reflective surface. And notice that it's coming in at an angle we call theta I, and theta I is referenced from the vertical from the plane mirror. Then we have the reflection, which goes away from the reflected light ray, goes away from the surface, and its angle is also taken from the vertical, from the plane surface or plane mirror, and we call that theta R for the angle of reflection. So based on this diagram, we see that theta I, the angle of incidence, is equal to theta R, the angle of reflection. And if we have this smooth surface, we would be able to see an image off of that surface. But now if we have a rough surface, then we can still view this as tiny little differential plane mirrors, but they're all at different angles, and so the light rays don't reflect off at the same angle for each of the little differential areas, and so because of that we can't get a clear image based on whatever the source is coming from. Now there's a couple of things that we want to look at here. If I have an object that's being reflected in the mirror to my eye, what I see is a virtual image that appears to exist behind the mirror. And that's the same thing if a person looks at themselves in a mirror. They see themselves behind the mirror. But we can do a ray trace and we can see how the angles of reflection are all equal based on what I'm seeing in the mirror and how those would be reflected back to the eye. And what it looks like is that this ray on the back side of the mirror makes it so that the person seems to be the same height. There's no distortion. And it's the same with the bottle here. The light rays are going to my eye. They all follow the same law of reflection and incidence. But if I extend where the rays bounce off of the plane, I can see these virtual rays going back to show me where in the virtual the the object exists. So we have real images, and these can be projected onto a screen or film or a piece of paper, just something that you can actually see the object. And you put it on a different medium. Then you have virtual images, and those exist behind the mirror. and can't be projected. So we've defined different image types. The last thing we need to define is, based on this mirror, we have a distance from this mirror that we call the object distance, DO, and we have the image distance, in this case behind the mirror, that we would measure. But this is the customary way of defining our distance to the object and distance to the image. And we'll find these definitions will change based on some of the different problems that we do. So we'll have to keep track of these definitions. And the definitions will be the direction that we consider the object distance or the image distance to be positive, and then we can work with negative numbers and understand what those mean. So let's look at some different um, reflection. Well, the next problem is an interesting problem, and I think there's actually one in the display at the lab, and we'll look at why it appears a certain way. So that'll be the next reflection example.